Hi class, welcome to this video on section 3.4 on patterning and linear relations. I'm going to go over the handouts we'd have normally done during class time. You can find these handouts on Google Classroom, should be in the same post along with this video, and complete them as I'm completing them as well. And then there'll be some Google form that you can fill out, like a self-marking quiz. And we'll go from there. All right, so let's look at this first pattern problem. We have here a pattern, you can see with the red circles. It says describe the pattern below. So if I were to describe using words, I would look and I would say, what did it start at? Okay, so the pattern starts with 4 dots. And how much is it going up by each time is the other thing I want to think about, right? So it had 4, now it has 8. And then if I look at this one, it has 12. So the pattern starts with 4 dots and goes up by 4. So I described the pattern below. Now it says to graph this pattern. And we just need to add values along the y-axis. So we're going to go 4, 8, 12, 16, 20, and we're going to graph these points. So the first point that I could graph here is 1 and 4. Term number 1 has 4 dots, and then number 2, which has 8 dots, and number 3, which has 12 dots. And you could predict the next ones are going to be here and here as well. I'm going to draw a line through them. Okay, so I graphed the pattern. Now it says, what is the rate of change of the dots? When it says the rate of change, it means how much did the pattern change by? How many dots did it increase by each time? All right, so it changed by 4, as we just said. So the rate of change is 4. It goes up by 4 each time. Now, what is the pattern rule? And the pattern rule is something actually that we'll come right back to. What I want to look at first is this table of values. Let's skip down to the table of values, F here. If you look at F, it asks you to create a table of values. Let's do that. So if there's position 1, how many dots were there? There were 4. Position 2, 8, 3, 12, 4, and 16. Now if you look at this pattern, you notice it's going up by 4 each time. And if we follow the pattern backwards, we could find what the value or the number of dots would be at an imaginary position of 0. I'd have to go down 4 more, and that would take me to 0. All right? Now this is important because this here tells me the initial value, this value right here. It's the value of y, the initial value. We'll write this definition down. The initial value is the value of y when x equals 0. All right, so you can see here x is 0. Position number is x, and the value of y when x equals 0 is 0. So the initial value for this relation would be 0. Okay, so now we want to figure out the pattern rule. And the pattern rule, we're going to be using an equation that looks like this. Y equals mx plus b. And y is always going to be our dependent variable. And our dependent variable in this case is the number of dots. So we do n, capital N. And the rate of change is m. That's the rate of change right here. So what value did we get for the rate of change? The rate of change was 4. And the position number or term number, same thing. We'll use the letter t. That's our independent variable. So 4t. B is our initial value, and we discussed that our initial value is 0, so plus 0. But do I need to write plus 0? No, I don't. So here is our pattern rule. n equals to 4t. Now I can also finish drawing the graph because we found out that 0, 0 was a point on the graph. So this is another part of that line. Okay, so now we're going to see a more a practical application of it, and then we'll look at some other patterns as we go forward as well. Alright, so if we look here, it says here the total cost of bowling at 10 stripes bowling is represented by the graph on the right. What is the initial value of the graph? Well, if you look here, what's the value of y when x is equal to 0? Well, the value is 0, so the initial value here is 0. What is the rate of change? And you've learned how to do rate of change or slope before. We go like this and this. We compare these 2 points. It's going up by 4. It's going over by 1. So 4 over 1 gives us a rate of change of 4. Okay, we create a table of values. Number of games is 0. We know the total cost was 0. If number of games was 1, 2, 3, 4, and 5, it's going to go up by 5 each time over here. Alright, now it says determine the, oops, sorry, not up by 5, it's going to go up by 4. Sorry about that, 4, 8, 12, 16, and 20. Alright, so now we can do the equation. In this case, we were doing the dependent variable was cost. The rate of change, or the slope, remember we're doing this form, y equals mx plus b. Y is our dependent variable, m is our slope. How much is the slope? Slope is 4. 4 for each game. N is our number of games, is our independent variable. And again, there is no initial value, so it's just c equals 4n. You can see it's the same equation we just did moments ago, but for a different situation, a more realistic situation rather than just a pattern. And how do we know if this is linear or nonlinear? Well, we know it's linear. The equation is linear because the first difference is, because the rate of change is constant. The relation is linear because the rate of change is constant. And so what does that mean? I mean, just look at this graph right here. You see it's going up by 4 each time, and that's why it creates a straight line. If it all of a sudden went up by 5, well, then you'd have a very different looking line. If it and it wouldn't be straight any longer. All right, let's look at this example here. Joe owns an auto repair shop. He charges his customers an hourly rate for repairs. The relationship between his income and the amount of time he works is shown in the graph to the right. What is Joe's hourly rate? Well, you can look here. If you find this point right here, this means Joe worked 1 hour and he got paid $75 an hour. Therefore, the answer is B. If we look at the next problem, it says the graph below represents the relationship between Jackie's salary and the length of time she works, and T, represented with T. What is Jackie's salary when she works 8 hours? So here in this question, it's slightly more work. We can look and we could find this point here. You can see that for 1 hour, Jackie was paid $10. So how much do you think they would be paid for 8 hours? Well, 1 hour is $10, so 8 times 10, and we get $80. Your answer is B. What is the rate of change in this graph? Again, if we do the triangle here, we can see it went up by 1. The run was 1, so 10 over 1, and the rate of change is 10. What does it mean in this situation? It means that Jackie is paid $10 per hour. All right, so that concludes this handout right here. I'm going to make another short video just going over patterning rules a little bit further and more in depth. So stay tuned for that.